our restless planet from Pangaea to 7 continents. Welcome to our journey through time, where we explore the incredible story of Pangaea and its transformation into the 7 continents we know today. Imagine a world where all landmasses were united, a supercontinent called Pangaea, surrounded by a single, vast ocean. It's hard to picture now, looking at a map, but this was our Earth millions of years ago. Over eons, this supercontinent would embark on an incredible journey, fragmenting and drifting apart, shaping the world we know today. The story of Pangaea is a tale of immense geological forces, dramatic climate shifts, and the evolution of life itself. Join us as we delve into the depths of geological time, tracing the movement of continents, the birth of oceans, and the incredible forces that have shaped our planet. Pangaea, the supercontinent. Around 335 million years ago, long before the dinosaurs roamed, the Earth possessed a very different geography. All the major land masses were fused, forming a colossal supercontinent, Pangaea. This behemoth stretched from pole to pole, a vast expanse of deserts, mountains, and nascent forests, teeming with strange and wonderful life forms. But Pangaea, though seemingly immutable, was not eternal. Deep within the Earth's mantle, forces were already at work that would tear this supercontinent asunder, setting in motion the creation of our modern world. Tectonic plates, the engine of change. The Earth's crust, far from being a solid shell, is a mosaic of gigantic plates in constant, albeit incredibly slow, motion. These tectonic plates, driven by heat emanating from the Earth's core, are forever shifting, colliding, and grinding against each other. It's this relentless dance of the tectonic plates that caused Pangaea to rift and break apart, initiating a process of continental drift that continues to this day. Continental drift, Wegener's vision. In the early 20th century, a German meteorologist named Alfred Wegener proposed a revolutionary idea: continental drift. He suggested that the continents weren't fixed, but rather drifted across the Earth's surface over millions of years. Wegener's theory, initially met with skepticism, would later be confirmed by the discovery of seafloor spreading and the understanding of plate tectonics. His work provided the framework for comprehending the incredible journey of Pangaea. Chapter 4: The Triassic Period, a Time of Transition. The Triassic period, spanning from 252 to 201 million years ago, marked the beginning of Pangaea's breakup. The supercontinent began to experience immense stress as rifts formed across its vast expanse. Volcanoes erupted with fury, spewing lava and ash into the atmosphere, while the land trembled with earthquakes. It was a time of dramatic upheaval, a prelude to the fragmentation to come. Chapter 5: Jurassic Period, the breakup begins. As the Jurassic period dawned, around 201 million years ago, the once united Pangaea began to split apart in earnest. A long, narrow rift, stretching for thousands of miles, appeared along what is now the eastern coast of North America and the western coast of Africa. This marked the birth of the Atlantic Ocean, a body of water that would continue to grow wider and wider as the continents drifted apart. Chapter 6: Cretaceous Period, a world transformed. The Cretaceous period, from 145 to 66 million years ago, witnessed the most dramatic changes in Pangaea's fragmentation. The Atlantic Ocean widened, and the southern supercontinent Gondwana began to break apart, forming the precursors to South America, Africa, Antarctica, and Australia. The Earth's geography was being redrawn, creating new coastlines, shallow seas, and diverse habitats that would foster the evolution of new life forms. As Pangaea split, it formed 2 smaller supercontinents. In the north lay Laurasia, comprising what would become North America, Greenland, Europe, and Asia. This immense landmass, covered in lush forests and vast plains, played host to a diverse array of dinosaurs and early mammals. Over millions of years, Laurasia itself would continue to fragment, its pieces drifting across the globe to form the continents we recognize today. South of Laurasia lay Gondwana, a vast landmass encompassing the future continents of South America, Africa, Antarctica, Australia, and the Indian subcontinent. Gondwana was a land of contrasts, with scorching deserts, lush rainforests, and icy polar regions. Its fragmentation would have a profound impact on the evolution of life, isolating populations and leading to the development of unique species on each newly formed landmass. As North America slowly pulled away from Eurasia and Africa, the Atlantic Ocean continued to expand. Molten rock from the Earth's mantle welled up at the mid-Atlantic ridge, creating new oceanic crust and pushing the continents further apart. This process, known as seafloor spreading, continues to this day, widening the Atlantic Ocean by a few centimeters each year. Chapter 10. Birth of the Indian Ocean. While the Atlantic Ocean widened, a new body of water was forming on the opposite side of the globe. The Indian subcontinent, once part of Gondwana, broke away and began a dramatic northward journey towards Asia. This movement created the Indian Ocean, a vast expanse of water that would eventually connect with the Pacific Ocean, creating the maritime trade routes we know today. The Pacific, a shrinking giant. While the Atlantic and Indian Oceans grew, the Pacific Ocean, once a truly vast expanse, began to shrink. As new oceanic crust formed at the mid-ocean ridges, older crust was subducted or forced back down into the Earth's mantle at the edges of the Pacific Plate. This process of subduction, while slow, has been reshaping the Pacific Ocean for millions of years. Chapter 12. Climate in Flux. The breakup of Pangaea had a profound impact on Earth's climate. The formation of new oceans, continents, and mountain ranges altered ocean currents, wind patterns, and the distribution of heat across the globe. These changes led to dramatic shifts in climate zones, with some regions becoming warmer and more humid, while others grew colder and drier. Life on Earth had to adapt to these new conditions, driving evolution in new directions. Chapter 13. Flora, Adapting to Change. The fragmentation of Pangaea and the subsequent climate changes had a profound impact on plant life. As continents drifted apart, plant species became isolated from each other, leading to the evolution of new and diverse floras. In some regions, vast forests flourished in the warm, humid climates, while in others, plants adapted to survive in harsh desert conditions. Chapter 14. Fauna, a world of diversity. The breakup of Pangaea played a pivotal role in the evolution of animal life. As continents drifted and climates changed, animal populations became isolated, leading to the development of unique species on different land masses. The dinosaurs, already thriving during the Jurassic, continued to evolve and diversify, reaching their peak during the Cretaceous period. The fragmentation of Pangaea set the stage for the remarkable diversity of animal life we see today. Chapter 15. Mountain building, a force of nature. The collision of tectonic plates, the same force that tore Pangaea apart, is also responsible for building some of the world's most impressive mountain ranges. As the Indian subcontinent collided with Asia, the Himalayas, the highest mountain range on Earth, began to rise. Similarly, the Andes in South America and the Alps in Europe owe their existence to the ongoing dance of the continents. Chapter 16. Volcanic Fury. The breakup of Pangaea was a fiery and explosive affair. As tectonic plates diverged and converged, magma from the Earth's mantle rose to the surface, creating chains of volcanoes along the edges of continents and in the newly formed ocean basins. These volcanic eruptions released massive amounts of ash and gases into the atmosphere, influencing climate and shaping the landscape. Chapter 17. Earthquakes shaking the world. The movement of tectonic plates, while slow and often imperceptible, can also trigger sudden and violent earthquakes. As plates grind past each other, stress builds up along fault lines. When this stress is released, it sends shock waves through the Earth, causing the ground to shake. Earthquakes have played a significant role in shaping the Earth's surface, from creating mountains to triggering tsunamis. Chapter 18. Sea level, a rising tide. The breakup of Pangaea had a dramatic effect on sea levels. As new ocean basins formed and continents moved, the volume of the ocean basins changed, causing sea levels to rise and fall. These fluctuations in sea level had a profound impact on coastal environments, shaping coastlines and influencing the evolution of marine life. Chapter 19. Ice Ages, a chilling effect. The breakup of Pangaea and the subsequent changes in ocean currents and atmospheric circulation played a role in the onset of ice ages. During these periods of global cooling, vast ice sheets expanded from the poles, covering large portions of the continents. Ice ages have shaped the Earth's surface, carving out valleys and transporting huge amounts of rock and sediment. Chapter 20. Human migration following the paths. The breakup of Pangaea had a profound impact on human evolution and migration. As continents drifted apart, they created barriers and pathways for early humans, influencing their movements and dispersal across the globe. The continents' positions shaped migration patterns, leading to the peopling of the Americas, Australia, and other distant lands. Chapter 21. Modern continents. A snapshot in time. Today, millions of years after Pangaea began to break apart, we see the continents in their current configuration, but this is just a snapshot in time. The continents are still on the move, albeit at a pace too slow for us to perceive. North America and Europe are drifting apart at a rate of about 2.5 centimeters per year, while the Pacific Ocean is slowly shrinking. Scientists predict that in the distant future, perhaps 250 million years from now, the continents will once again collide to form a new supercontinent. This future landmass, sometimes called Pangaea Ultima, would have a profound impact on Earth's climate, ocean currents, and the evolution of life. The formation and breakup of supercontinents is a cyclical process, a testament to the dynamic nature of our planet. Chapter 23. Scientific discoveries unlocking the past. Our understanding of Pangaea and continental drift is the result of centuries of scientific inquiry. From the early observations of mapmakers to the development of plate tectonics theory, scientists have pieced together the evidence to unravel the history of our planet. Fossil discoveries, geological formations, and the study of Earth's magnetic field have all contributed to our knowledge of this ancient supercontinent. Title: Technology advancing our understanding. Technological advancements, particularly in the fields of seismology, geochronology, and satellite geodesy, have revolutionized our understanding of Pangaea and plate tectonics. Seismographs allow us to track the movement of tectonic plates, while geochronological dating techniques provide us with accurate ages for rocks and fossils. Satellites equipped with GPS technology allow us to measure the movement of continents with millimeter precision. Title: A Journey Through Time. Our journey from Pangaea to the present day has been a tale of immense geological forces, dramatic climate shifts, and the evolution of life itself. The breakup of this supercontinent has shaped our planet, creating the continents, oceans, and mountain ranges we know today. It's a story that reminds us of the Earth's dynamism, a planet in constant motion, forever changing, forever fascinating. Outro title: Our Ever-Changing Planet. Thank you for joining us on this incredible journey through time. From the ancient supercontinent of Pangaea to the 7 continents we know today, we've witnessed the awe-inspiring forces that have shaped our planet over millions of years. The story of Pangaea is a reminder that Earth is not static, but a dynamic system, constantly evolving and changing. The continents continue to drift, oceans rise and fall, and life finds new ways to adapt and thrive. Don't forget to like, share, and subscribe for more fascinating stories from our planet's history.